So the last video for this section is on really, really small, rather than we did the really, really big for electric forces or gravitational forces. Now we go small and look at electric forces. Okay. So hopefully you already know some of this, but there's basically two types of electric charge. Like charges repel, unlike charges attract. You've heard this probably for like personalities too, but the same thing holds true with electric charges. If two things that are electrically charged, and electrically charged just means there's an unbalance between electrons and protons. If they have the like type of charges, they repel each other, unlike they attract. Okay, and for this, electric charge is conserved, which means they remain constant. Electric charge it can't be created or destroyed. It just changes amount. So positively charged particles are the protons, uncharged are the neutrons, negative are the electrons. So if something is negatively charged, it's going to have more electrons than protons. If it's positively charged, it's going to have more protons than electrons. If it's neutrally charged, no charge, it has the same amount of electrons and protons. And you might remember from chemistry that when we're adding and subtracting charge, we're really just moving electrons. Okay. So something that's negatively charged has gained electrons. Something that's positively charged has lost electrons, so it has a more positive charge. Now, everything that has an electric charge also has what's called an electric field. Okay? The electric field is measured in newtons. Okay, electric field strength is measured in newtons. And we're looking at the direction and looks at how it attracts something else. So we draw what's called an electric field lines, which show the direction of charges. And the number of electric field lines is proportional to the strength of the field. So the greater the number of electric charges, the greater the number of field lines. So like this one has a relatively small electric field. If it's a greater field, so greater strength of the electric charges, there would be more lines. Okay. Now, if we look at this, the rules, the electric field lines are always drawn from the positive charge to the negative charge. Okay. And the two field lines cannot cross each other. Okay. Mainly think about it like the beginning. These field lines have the same charge. So two like charges repel each other, so they can't touch. And then so charges go from positive to negative. They go out from the positive towards negative. And the more lines you have, the greater the electric field, the greater the strength of that charge. Okay. Now, the unit of charge is what's called the Coulomb. Okay, and the charge of an electron is 1.6 times 10 to the negative 19th coulombs. So very, 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 very small for one electron. Okay. It was actually they derived it with an experiment to figure out the electric charge. Okay. Now we said the unit of electric charge is coulombs. There is a rule called Coulomb's law. And the law basically says two charges near each other exert a force called an electric force. And this should look very, very familiar to you. This electric force equation is almost identical to Newton's law of universal gravitation. Okay, you have a constant, in this case it's called Coulomb's constant, is equal to the product of the charges divided by the distance between them squared. So the product of the charges is directly proportional to the electric force between them. Electric force is measured in newtons because it's a force. And the electric force is inversely proportional to the square of the distance, just like with Newton's law of universal gravitation. Okay, so there's going to be some practice problems with this as well. So when a body's when there's no net force acting on an object, it's called an equilibrium. So the Coulomb force, electric force, is a field force. It acts over distance like gravity. Okay. So a field force, again, it acts over a distance, kind of like gravity does. So what we're going to do now is we're going to do a sample problem. So here's a sample problem. If you have a 5 Coulomb charge and a 10 Coulomb charge separated by 5 meters, what is the electric force between them? So it also gives you the fact that Coulomb's constant is 9 times 10 to the 9th Newton meter squared per Coulomb squared. So we know that Q1 is 5 coulombs, Q2 is 10 coulombs, the distance between them is 5 meters, and Coulomb's constant is 10 to the 9th. So my formula is force is equal to Coulomb's constant times the product of the charges divided by r squared. So if I put in my numbers, Coulomb's constant, 9 times 10 to the 9th, times 5 times 10 divided by 5 meters squared. We do the top part, 5 times 10 times 9.9 times 10 to the 9th is 4.5 times 10 to the 11th. 5 squared is 25, so 4.5 times 10 to the 11th divided by 25 is 1.8 times 10 to the 9th newtons. Okay, so on your practice sheet, you're going to have to rearrange this equation to solve for the math answers for this. So this is the end of the video. Make sure you answer the questions, and we'll see you in class.